So if you see the overview of the rubber processing, then many of the production methods used for plastic are also applicable to rubbers. Then however, rubber processing technology is different in certain respect, and the rubber industry is largely separate from the plastic industry. The rubber industry and goods made of rubber are dominated by one products, that is tires, and tires are used in large number on automobiles, trucks and aircraft and the bicycles. So as we have seen, the many of the reactions or many of the processing techniques, they are very similar to the plastic, like molding, then the emulsion, polymerization and many things. But in one respect, the rubber industry overcome the plastic industry is the manufacturing of the tires. So tire manufacturing, we have the the plastic or polymer over there, but we need essentially the rubber for the manufacturing of the tires. So mainly when we are discussing about the rubber industry, we have to mainly focus on how to manufacture the tires. Then rubber processing and shaping. So two basic steps involved in the rubber good production. The first one is production of rubber itself. So the natural rubber which we get from the agricultural crop, and the synthetic rubbers which is based on the petroleum. So this serves as the raw material for the processing. Then next one comes is the compounding, then mixing, then shaping, and finally is the vulcanizing. So here the rubber industry, the production of the raw natural rubber is an agricultural industry, because latex, the starting rate is grown on the plantation in tropical climates. By contrast, the synthetic rubber is produced by the petrochemical industry. And finally, processing into tires and other products occurs at processor, that is fabricator plants, and commonly known as the rubber industry. And the company names include the Goodyear, then BF, Goodrich, and Michelin, and all reflecting the importance of the tires. So the rubber industry main product is the tire, which we have to see over here. So starting from raw material and the manufacturing, it will tell you what are the processes that happening in the rubber industry. So the natural rubber is tapped from the plant which have seen, and the trees are grown on plantation in Southeast Asia and other parts of the world. And latex is a colloidal dispersion of solid particles. The polyisoprene is the main constituent of it. So polyisoprene, which is the polymer of C5HN, it is a chemical substance that comprises natural rubber, and it contains in the emulsion is around 30%. The latex is collected in large tanks, thus blending the yield of many strains together. Then preferred method for recover rubber from latex involves the coagulation, adding an acid such as formic acid, and the coagulation takes about 12 hours. And the coagulum, now soft solid slab in the squeeze through a series of rows, which dry out most of the water and reduce the thickness to about 3 mm or 1/8 of the inch. The sheets are then draped over wooden frame and dried in smoke houses, and several days are normally required to complete the drying process. So the natural rubber which are getting, the acids are added for neutralization. Then whatever the soft material which we are forming, we are pressing it and then forming the sheets, and then sheets we are keeping for more days in order to have the complete the drying process. Then grades, if you see, the resulting rubber now in the form of rib smoke sheet is folded into large bales for the shipment in the processor. It has characteristics dark brown color, as we have the smoke one or the drying operation. In some cases, the sheets are dry in hot air rather than the smoke houses, and the term air dried sheet is used. This is considered to be the better grade of rubber. So instead of the direct heating, if you can have the dry or dry hot air, then that will be termed air dry sheet, which is of good quality. And still better grade we call the pale crib rubber, involves the 2 coagulation steps followed by warm air drying. So the EC color is light tan. So the different processing will give you different quality of the rubber, and that quality which you can manufacture into specialized products. The synthetic rubber, if you see, the most synthetic rubbers are produced from petroleum by the same polymerization techniques used to synthesize other polymers. Then unlike thermoplastic and the thermosetting polymers, which are normally supplied to the fabricator as the pellets or liquid resins, synthetic rubbers are supplied to rubber processors in the form of large bales. And the rubber industry has a long tradition of handling natural rubber in these unit loads. Then we have the compounding. So we have seen the raw material sources. Then compounding, if we see, the rubber is always compounded with additives. So it adds the chemicals for vulcanization such as sulfur, And the additive includes filler which act either to enhance the rubber's medicinal mechanical properties or to extend the rubber to reduce cost. Then it is through compounding that the specific rubber is designed to satisfy a given application in terms of properties, cost and processability. So these are the three points for which we have to do the compounding. Then carbon black and rubber. So generally we have seen the rubber we see is almost black in color. So the single most important reinforcing filler is rubber is carbon black. Is a colloidal form of carbon obtained by thermal decomposition of the hydrocarbons, that is soot, which we get. Its effect is to increase the tensile strength and resistance to abrasion, tearing and the final rubber product. Carbon also provides protection from the ultraviolet radiation, and the most rubber parts are black in color because of their carbon black content. Then other fillers and additives in rubbers, they generally have the China clays, that is hydrous aluminum silicate, reinforced less than carbon black, but are used when black is not acceptable. Then other polymers such as styrene, then polyvinyl chloride, then phenolics. Then recycled rubber add to rubber product, but usually less than 10%. Then antioxidants, fatigue and ozone protective chemicals, then coloring pigments, plasticizer and softening oils, then blowing agents in the production of foam rubber and more release compounds. Then mixing is done, so additive and the natural rubber or synthetic rubber, when this comes, then we have to do mixing to them. Then additive must be thoroughly mixed through the base rubber to achieve uniform dispersion of ingredients. Then uncured rubbers have high viscosity, so mechanical working of the rubber can increase the temperature around 150 degrees centigrade. And if the vulcanizing agents were present from the start of the mixing, premature vulcanization would result the rubber processor's nightmare. Then we have this two-stage mixing. So it is to avoid the premature vulcanization, as two-stage mixing process is usually employed. In stage 1 we have the carbon black and other no vulcanizing additives, and in the second we have the when stage 1 mixing completed, the cooling has to be allowed. Stage 2 mixing carried out in which vulcanizing agents are added. So here the sulfur is not added, and in stage 2 sulfur is added after drying the material. Then filament reinforcement in rubber. So many products require filament reinforcement to reduce extensibility but retain the other desirable properties of rubber. So if you see the example, then tires and the conveyor belt, then filament used for this purpose include cellulose, nylon and polyester. Then fiberglass and steel are also used, example steel belted and radial tires. Then continuous fiber materials must be added during shaping. They are not mixed like the other additives. Then shaping and heating process. So first is raw material, then compounding, then mixing, and the next material comes with the shaping. Generally that is done in molding. So shaping process for rubber products can be divided into 4 basic categories. First is extrusion, then calendering, then coating, then molding and casting. So some products require several basic processes plus the assembly work. So example are tires. So extrusion, so screw extruders are generally used for the extrusion of rubber. So the L&D ratio of the extruder barrel is less than the thermoplastics, typically of 10 to 15. Then die swells occur in rubber extruders since the polymer in highly plastic condition and exhibit the memory property. So memory property means the product or the material which we can remember its shape. So whatever the things you do with the material or the stress or strain applied, after relieving of the stress or strain, it can regain its shape again. So the memory word is used for them, and the general meaning we can take that it can regain its shape in original. And then the rubber has not been vulcanized in this till this step. Then calendering or coating, if we say, the stock is passed to a series of gaps of decreasing size made by the stand of rotating rolls. The rubber sheet thickness is determined by the final roll gap. So in this one, feedstock is added, and you can see the 2 rows which are anti-clockwise or the anti-directional to each other. When it passes, the gap will determine how much thickness of the material will be there. Then in this one we can have the coating also. So coating also we put in this process, and whatever the sheet stock which you got, we can send for the further processing. Then the roller die process. So in manufacturing processes in the first year, you have learned this roller die process. So rubber sheet will come here and it is passed to the roller, and then we can get the less thickness sheet. So the combination of extrusion and calendering that result in better quality product than either extrusion of calendering alone. So here the rolling die process, so rubber extrusion followed by the rolling is done in order to get the good thickness in the rubber sheet. In coating or impregnating fabrics with rubber. So an important industrial process for producing automobile tires, conveyor belts, inflatable and waterproof cloth tents and the raincoats. So calendar rolls is there, so they will move in different directions, and the feedstock, then we have this material in sheet and then fabric which is to be coated. So they are blended together and they pass to the sheets, and then sheet is again passed to the rolling, and then thickness will determine the how much thickness we want. Generally the thickness is maintained, only the fabric is added over it, and then we get the final roll up where we have the thickness of the coating. Then molded rubber products. So here molded rubber products include shoe soles, seals, gasket and seals, suction cups and the bottle stops. Also many foam rubber parts are produced by molding. In addition, molding is an important process in tire production. Then molding process of rubber. So it will include the compression molding, transfer molding, injection molding. Compression molding is most important because of its use in tire manufacturing. And curing or vulcanizing is some compression in the mold. In all three processes, this represents a departure from previous shaping methods, all of which use a separate vulcanizing steps. So major step in the tire manufacturing is the vulcanization step. So we will see in little detail what is meant by the vulcanization. So the treatment that accomplishes cross-linking of elastomer molecules to make the rubber stiffer and stronger but retain extensibility. So on a submicroscopic scale, the long chain molecules of rubber become joined at a certain tie points, the effect of which is to reduce the ability of the elastomer to flow. A typical soft rubber has 1 or 2 cross-links per 1000 units, and as the number of cross-links increases, the polymer becomes stiffer and behaves more and more like a thermosetting plastic, which is mean hard rubber. So effect of vulcanization, if you see, the effect of vulcanization on rubber molecules, that is the raw rubber, then the vulcanized cross-link rubber. So this is the raw rubber, and after vulcanization we can have this one. So the variation of the second include a soft rubber, low degree cross-linking, and B, which is hard rubber, which is high degree of cross-linking. So if you see over here, the unprocessed rubber, which is long chain rubber molecules, then if you have the high stiffness to it, then we have to increase the more stiffness. So here we can have the vulcanization where we can have the less cross links, so that will determine the stiffness of the rubber, or we can have the more cross linking. So here you can see the more stiffer than the A1, so A and B, so this becomes the soft rubber, whereas the more cross links which will give the more stiffness in the rubber. So generally this is done, this kind of rubber we require in the tire, because tire they are the bearing lots of load on them, so they should be stiff, otherwise they may get busted out. So it is necessary to have the vulcanization in the rubber manufacturing for the tires. In vulcanization chemicals and the time, if you see, when first invented by the Goodyear in 1839, the vulcanization used sulfur, about 8 parts by weight of sulfur mixed with the 100 parts of natural rubber at 140 degrees centigrade for about 5 hours. So vulcanization with sulfur alone is no longer used today due to the long curing times. So the other chemicals which are used now, that is zinc oxide and stearic acid, are combined with the smaller dose of sulfur to accelerate the and center the treatment. So resulting time is 15 to 20 minutes. So earlier it was 5 hours, but with the help of ZNO and stearic acid, we can get them into 15 to 20 minutes. Then the tire and other rubber products, if you have, so tires are about 75% of the total rubber tonnage. And other important products other than tire, they are the footwear, then seals or gaskets, then shop absorbing part, then conveyor belts, hose, then foam rubber products, and the sport equipments. Then pneumatic tires, which are the function of pneumatic tires on a vehicle, support the weight of the vehicle, passenger and cargo, transit the motor torque to propel the vehicle, and absorb road vibration and shock to provide a comfortable ride. Then tires are used in automobiles, truck, buses, farm tractors, earth moving equipment, military vehicles, bicycle, motorcycles and aircraft. and many more other applications we know. In tire construction, it is assembly of many parts. The passenger car tire has about 50 individual components. The large earth mover tire has many as 175. The internal structure of the tire, known as the carcass, consists of multiple layers of rubber coated cords called the plies, and the cords are on the strand of nylon, polyester, fiberglass or the steel, which provide extensibility to reinforce the rubber in the carcass. Then if you see the tire construction, then the braid coil, then we can see steel wires, then we have the fillers, the inner lining and diagonal pipes and the thread. So these are the different coatings we can find in the tire. So three tire construction, one is diagonal ply, then this one represents the belted bias, and the third one represents the radial ply. So here we can see the different layer which are present over here, and they are merged together. That gives the more strength to the tire, which we can see. In tire production sequence, so first one is the performing of component, then building the carcass and adding rubber strips to form the sidewalls and threads, and the molding and curing the components into one integral piece. And following description of these steps are typical. The variation exists in processing depending on the construction, tire size and the tire of the vehicle on which the tire will be used. Then performing of the components. The carcass consists of multiple components, most of which are rubber or reinforced rubber. These components and others are produced by a continuous process, then pre-cut to size and shape for subsequent assembly. And other components include the bed coil, plies, inner lining, belts, thread and sidewall, which I have seen in the diagram A, B and C. Then building of carcass. So carcass is traditionally assembled using a machine known as building drum, which main element is cylindrical arbor that rotates. So here you see the support drum on which the drum is resting on, and then tire is there, and the other material which is bead coil, then the colloidal drum for the tire removal is there, then building drum rotating by worker to facilitate assembly, and the thread strip. So all the material will be mounted on that one, and they will be pressed at once, and then we get the tire as which we see. So it is just before removal of the building drum, but prior to the molding and curing. Then molding and curing. The tire molds are usually split molds and contain the thread pattern to impress on the tire. So the molding. So first step we have the uncured tire. It placed over the expandable diaphragm like this one. Then in second stage we have the mold is closed and diaphragm is expanded to force uncured rubber against mold cavity, impressing thread pattern into rubber. Mold and diaphragm are heated to cure the rubber. So here it will be placed, then heated, and then we get the final tire the manufacturing. Another rubber products are the belts which we use generally. So they are widely used in conveyors, mechanical power transmitting systems. And rubber is an ideal material for this because it has the flexibility, but the belt must have little or no extensibility in order to function. Then accordingly it is reinforced with fibers, commonly polyester and nylon. Then fabric of these polymers are usually coated by calendering and assembled together to obtain the required number of plies and the thickness, and subsequently vulcanized by continuous or the batch heating processes. Then other things are plain hose, then reinforcement tube which consists of inner tube, then a reinforcement layer and the other layer. Then footwear we generally use, so main component is rubber. So it has the sole seals and the rubber overshoes and certain upper parts. So molded parts are produced by injection molding and compression molding and the certain special molding techniques developed by the shoe industry. The rubbers include both solid and foam. The low volume production manual methods are sometimes used to cut rubber from the flat stock. Then processing of thermoplastic elastomers. So TPE, thermoplastic polymer that possesses the properties of rubber. So TPE process like thermoplastic, but the application are those of elastomers. So generally they are more economical, faster than traditional process used for rubber that must be vulcanized. Then the products are shoe soles, athletic footwear, and the automatic the components such as the fender extensions and the corner panels. Then product design consideration. This is the last part of the module, which gives the economic production quantities. So here rubber parts produced by compression molding, the traditional process, can often be produced in the quantities of 1000 or less. The mold cost relatively low compared to that of the molding methods, and with plastic part, injection molding or rubber parts requires higher production quantities to justify the more expensive mold. Then draft is usually unnecessary for molded parts of the rubber because its flexibility allows it to deform for removal from the mold. And the shallow undercuts, although undesirable, are possible with rubber molded parts for the same reason. The low stiffness and high elasticity of the material permits removal from the mold. So these are the reference for the rubber industry. And the next time we will try to focus on the petroleum processing industry, and then the last industry that we'll see will be the plastic and polymer industry.